and welcome to this webinar. So my name is Heidi and I work in Nohau Solutions Finland. Today we have Christopher Seidel from ARM with us. He will tell us about moving to the new ARM Keil MDK version 6. But first shortly about Nohau. So Nohau was founded in 1986 and we serve our customers from 3 office sites, one in Malmö, one in Copenhagen and one in Helsinki. Our customers are located in Nordics and Baltics. And what is it that we then sell? So we sell tools that help our customers that do embedded software or systems development. And we also have a long history of providing trainings, mostly about embedded software related topics. And we also provide expertise services, mostly around the tools we sell. Now I will hand over to Christian. So Christian, you're welcome.
Thanks, Heidi. Yeah, as she said, my name is Christopher Seidel. I'm the product manager of Keil MDK. I'm working for ARM in Munich. I'm currently broadcasting live from our new office. We have just moved to a new location. And I will be talking about MDK version 6 that we have basically released earlier this year. And we just did some exciting new updates last week, and I will talk about that. It will not only be presentation. I hope I have enough time to give you some demo as well. Let me start with the slides, and I will turn off the camera now. I hope that we will have then more real estate. So, Keil MDK version 6. I hope you know Keil MDK already. If not, I will give you a quick intro about what we had so far. This is the agenda for today. I will give you the introduction. I will talk about the CMSIS-Toolbox and our new Keil Studio IDE. I will tell you more about real-time operating system options and our new middleware. We have changed with MDK version 6 our licensing mechanism, going from Keil node-locked licensing and FlexNet to user-based licensing. And I will talking about reference applications, and we'll wrap up with a summary. And as I said, I hope I have enough time for a quick demo then. So, what is Keil MDK version 6? It's a set of tools that are available to you for embedded development. And here in green, you will find basically the new additions or something that has changed in version 6 compared to version 5. So we have a new IDE called Keil Studio that I will show you later. We have a new debugger called ARM Debugger that is used in Keil Studio under the hood. We are using the CMSIS-Toolbox, which is an open source collection of tools that help you to build embedded projects in the new project format that we have created together with our industry partners like NXP and STMicroelectronics. Our virtual hardware is on board. We are using a so-called Artifactory now, which is basically a web service or web server that allows you to download tools automatically, which is especially helpful when you are using command line workflows or CI/CD DevOps workflows in the cloud. And which is really new, we are supporting Linux, Mac OS, and Windows. So far, the old Microvision IDE was a Windows-only tool, and with Keil Studio, the CMSIS-Toolbox, and everything that we have changed, we are now able to support all the major operating systems. Middleware, we had the middleware before. Why is it green then? Because our middleware is now free to use. Before we had 2 different editions of Keil MDK. that you had to purchase if you wanted to get access to the middleware. The middleware is now a free-to-use thing, and this is one of the exciting news that I have, that last week we have released the middleware version 8. So this is now available as a CMSIS pack. And the other thing that has changed is that in functional safety, if you buy the MDK Professional Edition, you not only get access to the FUSA compiler and the C library, but also to our functional safety runtime system that helps you creating functional safe embedded projects using our Keil RTX that has been certified for FUSA applications. Of course, we are using CMSIS packs for everything under the hood, so device support, board support, and the software components. And for the debug adapters, we of course support our U-Link probes, CMSIS DAP, and third-party like, for example, ST-Links. This slide here is an overview about the editions that are available and their pricing. As I said previously, we had two kind of high-end editions that contained the MDK middleware. As it is now free, it's free to use in all editions, MDK Community, Essential, and Professional. The Community edition is basically something that we have released to support people like students, hobbyists, makers. This is for non-commercial use and contains all the tools that you need. There is no code size limitation or whatever, or functional limitation. You don't have access to functional safety, of course, but apart from that, everything works as expected. And the MDK Essential Edition is our first commercial edition that works with all the silicon devices that are out there. Currently, we have more than 11,000 devices in the CMSIS database, and it is at a price point of $999 per year. And then we have MDK Professional Edition that adds functional safety, virtual hardware to the professional, to the commercial tooling, and that is $1,999 per year. I was talking about the Artifactory that we have now as an option to download the tools. Previously, in the old days of MDK version 5, we had only one installer available on keil.com or on our product download hub that was containing Microvision, the editor, the debugger, pack manager, compiler, everything in one quite big executable installer. So I think MDK v5 is now around a gigabyte. This is Windows only, as I have said. And now with the new Keil Studio IDE, we have now switched to Visual Studio Code, Microsoft Visual Studio Code, as the basis for our IDE. And there's only one extension that you need to install. This is called the Keil Studio Pack extension. And this, so the Keil Studio Pack, because it's a set of extensions. I think in total it's 8 or 9 extensions that will be automatically downloaded if you install this Keil Studio Pack. And then you require separate installation of these other tools. But this is nicely managed with a package manager that I will talk about in a couple of slides. And all these tools are available on the Artifactory. You can download them from there. And we still have the PDH, the product download hub, but this is where you get the FUSA stuff. And even we are currently considering to move the functional safety tools also to the Artifactory to make it available more easily. Now, let me talk about some of the baseline technology that we are now using in Keil Studio in MDK version 6, which is the CMSIS-Toolbox. And the CMSIS-Toolbox, as I said, is a set of command line tools for embedded projects. So this is the basis of our next generation software tooling. It is using CMSIS software standards. So basically everything in the CMSIS-Toolbox is developed around our CMSIS packs, which is the delivery mechanism for device and board support and software components. And the nice thing, it works in command line and IDE workflows. So you can use it either on your local command line on your machine, or also in so-called CI/CD development flows on, for example, GitHub or GitLab or whatever Git provider you prefer. Or if you have your own server on-premise, you can also use these command line flows, which help you to create better code quality by running certain tests, for example, once a developer checks in some code. The availability as the extension for VS Code is basically, it's kind of a GUI for these command line tools. So the GUI under the hood is then calling the command line tools. It supports multiple compilers, so ARM compiler 6, Clang or LLVM, GCC, and the IAR compiler. Our new middleware is also prepared to support these compilers. And again, very important, it supports all major host operating systems, so macOS, Linux, and Windows. How is this CMSIS-Toolbox integrated into the ecosystem? So we are using Visual Studio Code for the IDE. The CMSIS-Toolbox is the base technology, and the CMSIS-Toolbox itself, for example, uses CMake and Ninja for building, for reproducible builds. And it's using the public CMSIS packs that are available on keil.com/packs. It enables reproducible builds. It is used by multiple IDEs. So also Keil Microvision is now using the CMSIS-Toolbox under the hood, IAR, EW for ARM, and we also have support for the CMSIS for the Eclipse IDE via the CMSIS pack Eclipse. And other tools from silicon partners like CubeMX or the MCU Expresso config tools are using this as well. And it also helps with integration of AI ML use cases. We are currently working with TDK Sensei, formerly known as Kixo, and for example, Edge Impulse that are using the CMSIS-Toolbox and the tools that we are offering under the hood to do, for example, DevOps, MLOps workflows. Here, another view on the Artifactory I was already talking about. And here's the important thing that while you can download everything from the Artifactory, also using, for example, curl, we are using in VS Code a tool called VC Package, which is a package manager from Microsoft that again also works under all host operating systems. So you can use it also on Mac and Linux, and that helps you to install the tools on demand from the tools Artifactory, and with that you can get a consistent project-specific tool setup with different workflows. So either you are on a Git repository and use VC Package there, for example, or you use a MDK, the VS Code, and or an MLOps system or an SAS CI system where you then, for example, use direct access. So as I said, for example, curl to download something. That is totally up to you. It's very versatile. You can enable different workflows. And we have an example for a Docker setup, for example, on GitHub ARM software, AVH-MLOps. Now, let me talk a little bit more about Keil Studio, the new IDE. So we have this new IDE basically in two flavors. One flavor is a cloud-native solution, which we call Keil Studio Cloud. And this helps you, for example, if you come to keil.com/boards and you discover some possibilities or options if you are creating a new embedded project and you want to find out what options you have, what hardware is available. You can then import, for example projects directly into this cloud-based Keil Studio. You can build it there and download it onto your target hardware. We're using web USB technology there, so you can connect your browser directly to the target hardware. And later, when you want to do bigger changes or create your own project based on that, we have then the Keil Studio in Visual Studio Code, where you can then develop and verify your custom application functionality. And of course, later also deploy it to your custom design. So you create your, because in this, especially here, you usually start with a off-the-shelf development board, which you got maybe at a trade show or from your preferred distributor. And later, of course, you create your own custom hardware for your project. And then you can use Visual Studio Code, so Keil Studio, to deploy onto the target hardware. Keil.com is our first instance to check all of this. You can search for devices and boards. You can discover example projects, of course, documentation, user guides, and so on. And you can then directly import these projects in Keil Studio Cloud or download it onto the desktop to run them locally. Keil Studio Cloud, as I said, a zero installation cloud native IDE. It's currently based on an IDE which is called Thea. That is kind of the open source sister of Visual Studio Code, but for making the look and feel between the Visual Studio Code, between the cloud and the desktop tooling, the same. We are currently working on transitioning also to VS Code in the cloud. And once we have that, you will have exactly the same look and feel for the cloud and for the desktop. Desktop, I will give a quick demo later, so I will not talk too much about this slide here. And let me continue with the RTOS and the MDK middleware. I hope you all know Keil RTX5, which is the real-time operating system created by ARM. It's free, it's commercial level, so we have 10,000s of users. It's royalty free, you get the source code, so you can even change it if you like. We support all the latest and greatest in technology like ARMv8M and Trusted Firmware M. Of course, it's an RTOS, so time deterministic, and has a very small footprint. And we use that kernel under the hood for MDK middleware. Keil RTX is a native implementation of the CMSIS RTOS2 API. CMSIS is our great standardization effort for Cortex-M based microcontrollers. And we have an RTOS API there, and RTX5 does a native implementation. We have also packages available, for example, a CMSIS free RTOS. So if you would like to use the CMSIS RTOS API, but you prefer to use free RTOS, then you can do that as well. There are other implementations available, I think, for Azure. There's also a shim layer for Zephyr available. So the CMSIS RTOS API itself is already widely used in the industry, and you have different choices. Keil RTX5 is functional safety certified. So if you buy MDK Professional, you get access to the functional safety certified version with all the paperwork and everything you need. When you go into your final certification, it's PSA certified, so also secure. MDK middleware, as I said previously, only available with MDK Plus and MDK Professional. Now it's free to use for everyone, and we just released it last week. It consists of a networking stack, TCP/IP connectivity. We are supporting both IPv4 and IPv6, and we already had a couple of customers who went through a certification for Achilles Level 1. That's cyber resilience test suite from, I think, General Electric. And it worked very nicely with our networking stack. USB host, we support, of course, USB host and device. And we also have the options. So we have a lot of USB device classes that you can use. Some of them you don't need any Windows, Linux, or macOS drivers. So it's automatically plug and play. And then, of course, we have also a file system for all kinds of storage devices. We have FAT32 support and can also have simultaneous device access. So this is the MDK middleware. And again, it's now free to use. It's delivered in source code in the CMSIS pack. So if you want to use it in your next project, there is nothing against that. Let's move on to the user-based licensing. This is a new licensing technology that we're using throughout all the ARM products. So this user-based licensing enables us also to be a multi-platform. So if you buy now an MDK version 6 license, for example, you can use ARM compiler on a Linux machine with that license as well. This was previously not possible, as MDK version 5 was Windows only and was using the Keil node-locked licensing, for example. So that was not really possible. Now we are much more flexible here. So how does that work? Let's define the user. The user is anybody, anything that uses a license. So it can either be a human developer that is sitting in front of one or more machines, and we don't care how many machines he's using, as long as he's using the same user credentials, and this is how we determine the user. Or it can also be an automated build or CI process. So if you have a server that is running your CI tests, for example, then you can equip that server with one license because he is one user, and then you can run as many tests, CI/CD tests on that machine as you like. And yeah, as I said, the UBL license identifies users by their OS username. So you need to make sure, especially if you have developers moving between machines, they need the same login on all machines, but then they can use the same activation code, for example. Key concepts, we have basically moved now to term licenses, 1 year only. And we have a caching mechanism, so you can use it offline for up to seven days. It can be installed on as many devices as you want. It allows multiple jobs, and this speeds up, for example, compilation very much, because the licensing is not checked for every single translation entity, but it's only checked at the beginning. So compiling is also much faster. It can be shared between different users, but you have to be aware of these minimum usage period of 7 days. Backward compatibility. So if you want to buy MDK version 6, how can you enable older tools? So you need to be aware that UBL is only available since ARM compiler for embedded 6.18, which was released 2 years ago, or embedded FUSA also 2 years ago. If you want to have access to older versions of MDK version 5 or legacy tools, then you need to buy the MDK Professional Edition, because there we have a mechanism to create node-locked licenses out of the UBL. Because of course these older tools do not work with user-based licensing, and yeah, there are some limitations which you see here. Especially you need to run this conversion command on the machine where you want to use the licenses, so you cannot provide a different CID or something like that. You need to have that on that local machine. There is lots of help available on developer.arm.com/ubl, where we have the landing pages, an overview about the changes, guides for administrators and users. If you want to set up, for example, your own UBL server, how that is done. We have a couple of downloads, FAQs, and videos of how to set up a license server. So this is all available on this UBL landing page. Now let me talk about reference applications. This is a very interesting thing that we have also worked on together with our partners, where we had basically some requirements. Maybe before I talk especially about the reference application, how can we utilize CMSIS components? I was talking about the middleware, file system, network, and USB. And this middleware uses CMSIS drivers, for example. Yeah? If the USB network stack requires a USB CMSIS driver be present in your device support or board support, and then you can easily connect the USB stack onto your device. Network, for example, is using Mbed TLS if you want to do secure communication, so HTTPS, for example. And on top, of course, things like the user application uses the middleware, and IoT connectors that we have for AWS, for example, is using the networking stack, which is using the Mbed TLS, and so on, and CMSIS drivers for Ethernet connectivity. And to make this all work, we need standardized APIs. So especially the CMSIS driver APIs are now well established in the industry. I think roughly a quarter of the devices that are in the catalog offer CMSIS drivers, and the number is growing every day. And how does that help us with reference applications? So these reference applications are usually used to kickstart application development when using middleware. They use these defined APIs, which help you to run on different evaluation boards. And it uses so-called software layers to target the hardware. So software layers is a concept in CMSIS pack where you can define, for example, in a board support pack, you can define a layer for your board, and then you have connections that this board provides. So, for example, CMSIS USB device or CMSIS virtual I/O, and middleware or other software. It doesn't have to be middleware. It can also be directly the application software, if you like. Has also this connections entry in the layer, and it tells what kind of interface it consumes. So it consumes a USB device, for example, or a VIO. And with these connections, consumes and provides, you can make easily connections between a middleware, or let's call it a piece of software, and a board support pack or board support layer. And you can then, for example, retarget for different boards. Here it's an ST example and an NXP example. And it's pretty easy to simply switch between the two, because the middleware runs on top of these reference or on these driver APIs that are available through the CMSIS standard. With that, you can even do more combinations, because this was actually one of the use cases that NXP has approached us. NXP, you might know, is a big provider of ARM Cortex-M based devices, but they have also a big sensor division. And the sensor division actually doesn't care so much about if the end user is using an NXP microcontroller. They are, of course, interested in selling their sensors. And now with this reference application framework and all these APIs, they can create an SDK pack for their sensors, which connects to certain APIs And then it's actually possible to use, for example, these sensors on an Arduino shield and stack them on top not only an NXP board, but also, for example, STM32 boards. And when these boards in their board layer offer the correct APIs, like, for example, I2C or SPI, because usually these Arduino boards are using that, then it's pretty easy for the NXP sensor division to sell the sensors to customers who are using actually STM32 devices because they like them better or have certain needs or whatever. And so we can create compatible board layers for different vendors, ST, NXP, for FPGA images for our prototyping system, or also for virtual hardware. So you can then test these interfaces via simulation in ARM virtual hardware FEPs. So this is very versatile, and I will show that just in a minute. Here's the summary. On this page, I have lots of links for getting help, talking about the ready-to-run examples for the development board, documentation. We have so-called learning paths, which are very, very small pages that explain certain things, like, for example, how to install it, how to use UBproject's conversion. So if you are an old-time Microvision user and you want to move over to this new CMSIS-Toolbox and the new project format, we have a conversion tool available. We explain how to use the CLI, for example. Then we have lots of videos available and webinars. The first one, Mastering DevOps of Embedded Systems, I did with Nohau earlier this year. And then I have also a list of video tutorials about Keil. So this is then the actual summary, Keil MDK version 6. We have lots of new components, the VS Code-based IDE, fast model runtime, FUSA RTS in MDK Professional, the command line tools, the free-to-use middleware, and thousands of example projects that are available online. The editions have been simplified, so we have only the non-commercial community edition, the commercial essential edition, everything for Cortex-M software, and the professional edition, which adds fast models and functional safety. And with that, this is basically the end of the presentation part. And now let me bring up the IDE to maybe give you a quick demo or two. Wait a minute, I need to stop sharing here. So you should see my screen. Make this a little bigger. So this is Visual Studio Code. I have installed the extensions. If you take a look here at the extensions, you see a lot of ARM extensions. The only thing that you have actually to install is where is it? Sorry. The Keil Studio pack. Because this is an extension pack consisting of 6 different extensions: the CMSIS solution, the device manager, environment manager, virtual hardware, ClangD for IntelliSense, and this is the pack. So you only have to install this one, and then it will automatically download all the others that you need. And now let's start a new project from scratch. And this is actually, if you click on this CMSIS icon here, you get this presented. Here you can start with a new solution or convert from a Microvision. I will start now with a new solution. And then you get the choice, where do you want to start? And you can either select a development board, or you can select a target device. And this selection here is currently based on the CMSIS packs that you have installed. Here I'm now using, for the simple one, an ABOF starter kit. ABOF is, I think, a Korean or Chinese silicon provider, Cortex-M0+. So I select this one, and then I can select what kind of project I want to use. ABOF has lots of demo projects in their CMSIS packs, which is great. But we also have a template for our blank solution. And I start with that one, as this is an easy one. I give the project name my project. Here you can select which compiler you are using, because I have installed compiler 6, GCC and LLVM. I'm staying with compiler 6. For the solution name, I just say my solution, and then I select a location. I use work projects above, and I create a new folder. I call it Nohau, and I open that one. And here I can, for example, select to initialize directly a Git repository if I want to use Git as a source code versioning system, and I say create. And then the project is automatically created. Some things happen in the background. For example, I have this VC package configuration JSON file, which tells me which tools need to be downloaded. And I see down here, 7 tools have been downloaded and added to the VS Code path. So from within VS Code, I can use these tools now. And a C solution file has been created, which is the basis for a project. It tells which packs are used, different target types, build type. I have a debug and release type out of the box. And then it refers to a project. And this project is under my project, a C project, and the project defines which are the source files and which components are used. This, of course, I mean, this is very texty, but it is YAML. We have chosen YAML because it's quite easy to read for humans. Previously, we had all the time XML files, and XML is hard to read, to be honest. And YAML is much easier to read. But still, we also have other means of checking what's going on here. So in this VS Code, in the CMSIS button, we see, for example, then the source files. I can open here and can start editing. This is a comment. No need to tell you about C, I hope. And here are the components. So for example, device startup and system files, they are automatically copied into the project. And one nice thing that we have with the new development flow is that also linker stuff is much easier than previously. We have a so-called regions file that is automatically generated from the information that is in the CMSIS packs, and we also have a GUI view of that. So if you click on that little icon, you can then start with ROM configuration, and you see is RX memory IROM1 from DFP. So this is the entry from the device family pack, the base address, the region size. We have a stack and heap configuration. You can do that here. And that's very easy and intuitive here. It's a header file. I mean, you can, of course, read and find it, but we're using the configuration wizard annotation to be able to have such a GUI view. And then together with this linker script source file, we then use these ROM base, ROM size entries to generate the scatter file. And we have just created this very simple example, and we can already build it. So here's the build button. And we see the build summary, it has succeeded. I think there is one warning because the, sorry, now I have one warning because it's still using, the startup file in assembler. We today recommend to use C files, but this is something that the Silicon partners have to put into their device family packs, but it already works. So with that, it's really, really easy to set up a project that is running just within minutes. Now I show you a bit more sophisticated example. I close this one here. And I again start from scratch, a new solution. And I select now the BU5 board from STMicroelectronics. And with that, I not only get these templates, but also reference examples from our middleware. So I could, for example, check here the USB device. The solution name is USB device, let's say, call it Nohau. I again select a location, projects, ST, let's name a new one, again, Nohau. I select that and I create it. And now some magic happens in the background. I get a new option here because this, as I said, this project or these reference examples are based on layers. And here, if I had different options, I could select different options. Currently, from the packs that I have added to my system, I have only the option for this U5 board, and I have also this one gives me only the ARM Compiler 6 selection, so I just say OK. And then everything is created in the background. And for example, here you see lots of, this is source control, so Git. These are untracked files that I can, for example, add and so on, because they are newly created. Taking a look at CMSIS, now, of course, we have many more components. We are using the RTOS under the hood, USB core component, device HID. We have the layer from the board. So this is the board layer, and the board layer brings its own components. Yeah, so this is much more sophisticated. And we also have different options now. I go to manage the solution settings. We have only one target added, but we have different active projects. So this USB device reference application already creates different active projects. And I now select my storage and virtual COM. I can select the build type, debug or release. I can also create configurations here. So run configuration, for example, if I had a board connected, I can flash it directly after building. And I have also a debug configuration for ARM debugger. And these configurations then are basically created in these launch and task JSON files. So this is the ARM debugger, and this is the flash configuration that is required by VS Code to work with this. Just deselect virtual COM, and I can then also directly build that. And yeah, 70 files built, succeeded. So very easy, and you can then straight ahead go and download it and start debugging. This is my demo so far, and I now stop sharing.
So thank you, Christopher. So that was very interesting. So we had a couple of questions here in the QA section.
Okay. I see one question. Does that mean we are not able to get floating licenses anymore? Currently, you can buy floating licenses until mid of next year. And then you have another year of S&M, and after that, floating licenses are gone. Basically, yes.
Yes. The first one, perhaps it has been deleted, was about like if you have like both Microvision and the UBL, Cloud, Keil Studio at the same time. So it's one license, okay.
So for Keil Studio Cloud, you don't need a license at all. It's just a website. You need to create an ARM account, and then you can log in and use it. So this is not license managed. You can start today. Studio.keil.arm.com, I think. The one that is license managed is MDK version 6, so the desktop tooling. So if you want to use Microvision or Keil Studio or the ARM compiler, then you need a license for that.
Okay, thanks. Then there's like a interesting question. So what value does the Keil product bring? compared to open source? I think this is like a long debate versus
it's a long debate. I would say that our expertise, of course, is especially in the debug part that I have not touched today too much. Yes, everyone can today quickly kind of glue together a tool chain based on open source compilers with GCC and open source IDEs and whatnot. It's really not witchcraft, or rocket science. But when it comes to debugging, then usually things start getting nasty. And especially in microvision, we have over 20 years of debug experience, which is really hard to match with open source tools.
Yeah, and it always helps that if you have some problems, you have a company to contact.
That's of course the other thing. So if you have problems, yeah, contact Nohau. They have their own experts. And of course, yeah, as a last resort, we have our support team, of course, answering questions as well. And this is something that is also not always available, or let's say, not available in maybe the time that you need. Yeah, in open source, somebody might take a look at your problem or not, and this is different with professional tools.
Yeah, and if it's like a serious bug, so you need to fix a product that's out there in the market, so it helps that someone else will fix it to you, so you don't have to try to spend a year or two or something fixing it. So, and one benefit that I feel is very important to our customers. So many of our customers need to take into consideration the functional safety and the requirements it brings. So now the Keil Professional includes components for functional safety by default. So I think that's a really, really good benefit included in the product.
Yes. I see another question. Currently, we have MDK Pro license renewed year after year. Could we discontinue renewal of UV and purchase a new BL? So what I would suggest is that you buy now, so when the old MDK version 5 expires, you buy an MDK version 6, because once again, to be very precise, you still get access to microvision. Microvision 5 is part of MDK version 6. So you don't have to be afraid that we are taking anything away from you. No, you get even more if you buy 6, because you not only get microvision, but you also get Keil Studio. So yes, I would suggest next time you renew, upgrade to MDK version 6, use UBL, and you get access to all the tools I was talking about today.
Yeah, including the legacy tools. Right?
Including the legacy. Well, that depends a little bit on which edition you are using, but this user was MDK Pro. Yeah, with Pro you also get access to legacy tools, so you have all the history of MDK version 4, 5, and 4, and ARM compiler 5, and whatnot. So that's all available to you then.
So
new question. MDK Pro offers free complete license for STM32F0. Is that extended in Keil 6 as well? Yes. So there is an application note available on developer.arm.com that explains how to use the free STM edition with MDK version 6 as well.
Okay. So last note about the functional safety. So Christopher mentioned briefly about the pre-certified middleware network component tested with the Achilles, which can provide a communication robustness certificate that's required in some industries. So like if you need to in addition to this pre-certification, if you need a certificate or you need to test your own product, so please contact Nohau. But thank you, Christopher, and this has been really interesting and useful. So hope everyone got what they were looking after, and if you have something in your mind, just contact us.
Thank you, Heidi, for having me, and thanks for all listening to me. And I wish you a great rest of your day.
Yep, thank you. Bye.
Bye.